biomedical signal processing using AI techniques. With that, let us warmly welcome Dr. Amit. So, can you please unmute yourself?
Yeah. So, am I audible, ma'am?
Yes.
Okay. So, first of all, thank you for the invitation for the conference ICCEMB 2026. So, today I am going to present on the topic biomedical signal processing using machine learning approaches. So, today I will cover what is the motivation behind choosing this topic, then what is the biomedical signal processing, and what is the need and introduction about the signals. Then I will discuss about few algorithm, basic algorithm like Hilberton transform. Then I move to the some advanced learning technique, which is known as reinforcement learning technique. So one algorithm of reinforcement learning technique is Q-learning. So I will discuss about this. Then I will move towards reinforcement learning based classification, then my contribution in the research, and then references. So first of all, what is the contribution, what is the motivation about this topic? Why I have choose this area? So as we know that real world signal, like if we are talking about any signal, their behavior or their characteristics are non-linear and non-stationary. Means they are with the time they are changing in any shape, or we can't fix their frame size. So traditional method, we suppose we are choosing the traditional mathematics. Suppose we are using linear equations or all these things. So they are unable to analyze non-linear system and non-stationary signal in a better manner. So we are proposing a techniques that can work for non-linear and non-stationary behavior signals. Though we can assume all we want, the reality can't be bent by the assumption. This is the quotation given by Annie Hong. So we are using a PIA for adaptive data analysis techniques. The crux of the matter is that method has good performance measure is a prerequisite for any prediction in the medical line. So we are using adaptive intelligent techniques, which will definitely help healthcare professionals so that they can deliver high quality care, achieving best clinical outputs. So biomedical signal, if we are talking about the engineering principle that match with the healthcare field, they are they are imparting the gap between the engineering and medical areas. So medical person use innovative education tools such as realistic simulation, web-based online resources, or humanistic models. It combines the design and problem solving skill with the engineering and the medical and biological sciences to solve and improve the healthcare diagnosis and the treatments. So what is the adaptive intelligence? Nowadays, we are talking about the artificial intelligence. So it is the analytical layer of the AI and machine learning application. It is the just a intersection of human judgment with the machine automation. So it has the capability of understanding and adjusting the analytical model input and training the data and improve imperfection and apply these ethics to use and interpretation of the data. So adaptive intelligent application in the new category to change with the time, self-learning application, biomedical signal processing, nonlinear control system application, web-based education, and many more areas in which we are using adaptive intelligent technique that can change with respect to the time. So algorithm, basically, I am discussing about the Hilbert-Hong transform. Why I have choose the Hilbert-Hong transform? Because firstly, we are using the Fourier transform, but the Fourier transform is the combination of sine and cosine signal that are used to decompose nonlinear and non-stationary signal, which is not sufficient. So better version, we have going for the wavelet transform, which have some mother wavelet and different shape, but it is unable to handle the non-stationary behavior of the signal. So moving ahead, we have used the Hilberton transform, which have the capability to handle non-linear and non-stationary behavior of the signal. So it basically decomposes the signal and find the intrinsic mode functions. So the application of Hilbert transform to find each mode yield complete time, frequency, energy representation of the signals. So in the Hilberton transform mathematics, I have shown here, in which the signal are decomposed and we are able to find the amplitude and the phase of any function, and the angle means angular frequency we can calculate through this decomposition. So basically this is a flowchart of Hilberton transform, in which we have suppose signal, then we are just applying a envelope, upper and lower boundaries, and interpolate a maxima and minima to connect them by the cubic spline method. Then we will calculate the average value. The average value is in each step is subtracted from the original signal, and we will repeat this procedure until we get the monotonic function or the linear function, so that we can apply the mathematical equation after getting the linear signal. Next algorithm which I am discussing is Q-learning algorithm. It is the algorithm which use the concept of the reinforcement learning. Now, the very popular learning techniques, very popular means because previously we are using supervised and unsupervised learning techniques, in which in the supervised learning technique, there should be we know the input and output both. Based on this, the classifier is able to take the decision. But in the case of unsupervised learning, we have the input data, we have some target value, but our agent or our, you can say, classifier learn by the behavior value. But in case of pure learning, we don't have required the input or the output. It will work on the reward and punishment scheme. Suppose a baby start crawling, the first time when he start crawling, then he do not know how to take the first step. So first he or she take the first step, he will fall down sometime, he will move in the other direction. So by their training itself, at after some time or some iteration, they are capable to crawl or they can stand and walk properly. Similar way, if we are taking the example of driving a car, so first we don't know about how to apply the clutch, how to apply the brake, gear, and all system. But with experience and with the reward and punishment, if you are doing the correct, if you are pushing the correct position or taking the correct clutch brake or acceleration, then we are getting the reward, means we are moving in the good direction. Otherwise, if we are taking instead of brake, we are accelerating, means we are doing something wrong, then we will get punishment as the form of the accident. So with continuous adaptation, a person is able to take their decision by itself. So this method is working on the phenomena of reinforcement learning. So what is reinforcement learning? It is the agent which is continuously interacting with the environment, and based on the interaction, he is getting the reward or the punishment, and a person is able, or our classifier is able to take the decision whether it is good or bad. And with number of iteration or continuous learning, our agent is trained so much that it will able to take the correct decisions. So this is the mathematics of Q learning, in which we are using the Bellman's equation. So I'm not going in the detail of this. Actually, I will show my results basically. Next, we have used the neural reinforcement learning classifier. What is the problem with the reinforcement learning is, if we are taking each step action, if we are, suppose we want to store the each action and their result. So our Q matrix size will be increased. So with each action or each step, we are getting the number of values. And for if we are increasing the number of iteration, the Q matrix storage size will be increased. To deal with this behavior or deal with this matrix size, we have to take some approximation functions. For this, can use the neural network. We can also use the fuzzy system. So in our first attempt, we have used the neural reinforcement learning classifier. What we have did in this, we are storing the value in using the approximation function, in which suppose I have previously discussed we are using the Bellman function or Bellman equation for the storage. So in this Q value, we have added a one parameter, weight parameter. If you are talking about ANN, artificial neural network or neural networks, then we have the weight input, weight and bias value. So we are basically tuning the weight of the neural network through the Q values. So this weight parameter will automatically tune with the reinforcement learning and give us the proper reward or punishment based on the actions or the based on the classification procedure. So this is the schematic diagram for the neural reinforcement learning classifier. Here Q values, and this is the tuning signal by shown by the dotted line. This is the aggregate function or the aggregate action we have to take. This is the reward function RK I have shown here. This is tuning parameter or tuning signal. So what is our contribution in the research? We have used the forearm movement classification using neural reinforcement learning techniques. So we have to choose an electromyograph signal, and we have acquired for the 20 subject signal which are healthier and their age is lies between 80 to 30. And we have chosen six forearm movements: hand close, hand open, supination, pronation. Like this, we have chosen six movement, and we have recorded the data of 20 subjects for the 5 minute recording of each section. And based on this, first we have applied these are the characteristics of the EMG signal, which ranges plus to minus 5 millivolt, and their muscle membrane's potential is a minus 70 microvolt. The typical muscle firing range is about 7 to 20 hertz, and range of unit can be expected from 450 to 780 millivolt. And the sampling frequency we have choose 1000 hertz because it follow the Nyquist criteria. The sampling frequency is twice of the FM. So in the working methodology, first step, we have used the surface electrode and we have used the BioPack 100 series system. This is the system for signal acquisition. After acquisition, we have applied the decomposition, and then we have extracted feature, time, frequency, energy based feature. We have calculated like mean value, max standard deviation, maximum value, entropy, enthalpy. So different value we can extract, and then based on this, we are classifying the different movement. These are task one, task two. These are the tasks we are used in our work. So in this work, we have used 21 time frequency amplitude based feature, and then we have classified these signal with the help of the artificial neural network. So these are the EMG signal. This is the channel setting of the BioPack 100C that we have used for our work. These are the movements we have captured. This is our system, BioPack 100C system. We are acquiring a signal for different movements. So this is a basic step of the decomposition. So this is the first one is the original EMG signal. Then we are applying a cubic spline on this and finding the average value, which is subtracted from the original signal. And in at the last, if you are saying in the last IMF function, the signal is almost linear or monotonic function. Its behavior is not moving in the both direction. It is just on the one direction only. So based on this, we have calculated the feature like mean, standard deviation, energy, entropy, maxima, minima, and difference of the maxima and minima. So these 7 feature for each domain we have calculated for frequency, time, and amplitude. So 21 feature we have calculated. So in ANN based classification, we have used the input matrix of 21 feature cross 10 subject for 6 movement we have used. So 21 cross 6 matrix we have used. Then target matrix is 6 cross 60 because we have 6 movements for 60 instances. Based on this, we have set the input and the target of ANN. After this, we are getting the, we have used 80-20 ratio of the training and testing. And then this is the overall confusion matrix then for a one movement. And it's, if you are able to see in the all confusion matrix, we have got the 97.5% classification accuracy for our one movement. Similarly, for different number of IMF level, we have calculated the accuracy and we are able to find the maximum accuracy at IMF level 1. So we have choose IMF level 1 and same we have repeated for different number of hidden layers. So at if we are choosing hidden layer size 10, then we are getting the maximum classification accuracy. So these are the table for left hand and right hand movement classification. And at the last, I have took the average of all the movements like 6 movements, hand close, open, flexion, extension, supination. And the average, we are getting approximately about 90% results for the accuracy. If we are going to plot the scatter plot for these movements, so you are, if you are drawing the scatter plot for the different domains like amplitude mean, frequency mean in between this. then you are able to clearly see the difference of the feature we have calculated. On that, they are exactly calculating the different movements. So we are getting the average accuracy for the left and right hand is 85.8 and 86.2%. The result indicates subject-wide movement for IMF level 1 with 10 number of hidden layers. The technique can be practically implemented for prosthesis design for the movement classification. Next work, we have covered the reinforcement learning classifier for elbow, finger, and hand movements, in which we have used this experimental setup in which we have used the shoulder movement and with the varying weights, like our shoulder is and our palm is set at different angle, like 10 degree, 20, 30, up to 90 degree we can set, and weight we are varying from 1 to 5 kg. And we are try second task we have used typing task, like we have used Amit fingers AMIT for typing finger keys we have used for the classification purpose. And third, same work for 6 forearm movement we have classified. So with this, we have got the success rate of different subject, like we have used 10 subject and used 10 feature we have extracted, and we have got the accuracy about 70.83% at different varying loads. And with two channel analysis, we have got the accuracies more than 90%. So this is for the finger task classification, in which we have choose for our work key typing key task finger like AMIT, and we have got the accuracies are about 98.75%. So same like previous, we have drawn the scatter plot in which amplitude mean value is plotted for the different channel 1 and channel 2, and we are able to segregate the different keys values based on their feature are separated properly. In the forearm movement classification task, we have got the accuracy about 97.6% with the NRL, which is far better than the ANN classification. So this is all about my work. Thank you for listening patiently. And this is my email, amit.kakkad@gmail.com. I am open for the discussion. If anyone have any query, please ask. Thank you very much for your time and patiently listening to me. Thank you so much. Any
Thank
query,
you so much.
please?